2.7 inverse functions, video 3. One of these times I'll remember to change that before I start the video. Homework due Friday, May 22nd, 2020 at 11:59 p.m. We're still looking at problems relative to questions 1, 2, and 3 on the homework. So let's take a look at one more example of verifying inverses. Let's determine if the following functions are inverses. F of x equals x squared, g of x equals the square root of x. On the surface, you might go, well, yeah, they undo each other, don't they? And the answer is, you'd be surprised. I mean, we could check it real quick. Remember what they're supposed to do. One of them is supposed to turn it to a number, the other one turns it back. So for example, if you give me a number and I square it, like let's square 7. 7 squared is 49. Now give the 49 to this guy. Square root of 49 is 7. Took us right back where we started. But what if I told you that doesn't always work? Wait, what? But we've been using squares. I know what we've been doing. But what if I told you that these actually are not inverse functions? Would you believe me? Let's find out. Step 1, g of f of x. G of f of x. And let's do this super efficiently. This means g of f of x. We would set it up by writing the outer function but replacing the x with parentheses. So let's write the g function but replace the x with parentheses. And then inside that, fill in what f of x equals, the inner function. F of x equals x squared, so x squared is going to go here. Don't those cancel? Don't squares and square roots cancel? Well, I'm going to write equals x, but I'm also going to write sort of. Because in a minute, I'm about to rattle your foundation subtly and then tell you why I haven't lied to you. So the square root of x squared equals x, sort of. Again, you'll see why in a moment. Let's do it the other way around. F of g of x. Again, let's be efficient. This means f of g of x, and we would set up the composition by writing the outer function, but with parentheses instead of x. So we're going to write x squared, replacing the x with parentheses. And then inside the parentheses, write what the inner function equals. In this case, it equals the square root of x, so that will go here. And now you're probably reluctant to say they cancel. I'll go ahead and tell you that this one is a definite yes. This one is always true. Now, I just kind of suggested that the one above it is not always true. I also suggested that with sorta, but don't worry, I will let the cat out of the bag in a moment. Let's check domains and ranges, shall we? One way to check domains and ranges, or to determine domains and ranges, is to look at the graphs of a function. Graphs of the functions. Now, we've already talked about f of x equaling x squared being a parabola. Looks like that. Let's go ahead and pull off its domain and range. I'm just going to write d and r. For specificity, I'll put df for domain of f and rf for range of f. This parabola goes forever left and right, so its domain is negative infinity to infinity. It's a polynomial function, that was no surprise. But the range is not the same because it does not go down forever. It only goes down to 0, so the range starts at 0 and goes up to infinity. Now remember, these don't have to be equal. The domain of one has to match the range of the other. So let's take a look at the graph of g of x equals the square root of x. Now, way back in the videos for 2.1, I believe at the end of one of them, I showed you the graphs of some basic functions, and this was one of them. I believe I told you that the graph of g of x is the top half of a parabola opening to the right. Remember, it can't be both halves because then it would fail the vertical line test and not even be a function. And there is no graph over here because over here the x's are negative. And when we graph, we don't graph imaginary numbers. Sticking negatives here would cause that to happen. So let's pull the domain and range off of this function, domain of g. domain is left to right, so it's from 0 to infinity, including 0. Which is also consistent when we talked about finding the domain of a square root function, making sure the radicand is greater than or equal to 0. But what's the range of g? Bottom to top, the lowest value is y, and it slowly goes up forever. So the range is from 0 to infinity. Does the domain of one function match the range of the other? Well, in one case, yes. The domain of g matches the range of f, so we're okay there. If we look at the other pair, the domain of f and the range of g are a mismatch. According to the definition of inverse functions, they're supposed to be the same, and they're not. So, what does that mean? It means these aren't inverses. Which surprises a lot of people. I thought squaring and square rooting were opposites. Well, under the right conditions they are, but in general they aren't. Here's why. Whatever goes into the f function might not be able to come out of the g function. Because remember what this means. Saying that the domain of this function is all real numbers means I can put in any number I want. And saying the range of this function is 0 to infinity is saying I can get out any number as long as it's at least 0. So there are numbers that I can put into the f function that I can't get back out of the g function. What number belongs to this domain but not this range? Or what numbers, I should say? The answer, all the negatives. This domain contains every number, positive and negative, every real number. This range only contains non-negative numbers. And by the way, the opposite of negative is not positive. The opposite of negative is non-negative. Because if you say the opposite of negative is positive, that leaves out 0. 0 is not negative, but it's also not positive. So the opposite of negative is non-negative. The range here are all the non-negative numbers, so it cannot give me back a negative number. So let's take a negative number and see why this doesn't work. Remember earlier when I said give me a number and we'll square it, and I said 7, great, 7 squared is 49. Put the 49 here, square root of 49 is 7. We're back where we started. But what if I'd given you negative 7, which is in the domain of f? Take negative 7 and square it. What do you get? 49. And what's the square root of 49? Now, before you say negative 7 or plus minus 7, both of those are incorrect. The square root of 49 is 7. Ask your calculator. As a function, this can only give me one answer. And I think we'll all agree that the square root of 49 is 7, not negative 7. So if I start with a negative number and square it, I cannot get it back. That's why these are inverse functions. That's why it's important for the domain of one function to match the range of the other, to guarantee that no matter what number you put in here, you can get it back. But for this one, I can give this negatives, but I can't get them back. So that's why it's important for the domains and ranges to match. Now, there's another issue that I'm going to go ahead and do next. It was going to be towards the end of my video series, but I think now would be a natural time to discuss it. Not in this video, but the following one, instead of waiting for it until the very end of the